In a previous lesson, we learned about transforming or rewriting quadratic equations into its standard form. We know that the quadratic equation standard form is written in the form ax squared plus bx plus c. Also, you learned last meeting about identifying or determining the values for a, b, and c. So this time, let's learn how to solve quadratic equations by factoring and by using the quadratic formula. At the end of this lesson, we should be able to, number 1, solve quadratic equations by zero product property or factoring, and number 2, which will be presented in the part 2 of the lesson, is to solve quadratic equations by using the quadratic formula. So in this lesson, we'll only take the first objective, and the second objective will be presented in the part 2 of the lesson. During your previous years in high school, you were taught about the different factoring techniques in factoring polynomials. I believe you were taught how to factor polynomials using the greatest common factor, special product or special form, how to factor quadratic equations, as well as factoring using the grouping method. So your prior knowledge about that lesson will help you understand this lesson on solving quadratic equations by factoring easily. Please take note that when solving quadratic equations by factoring, the following steps must be observed or must be followed. So number 1, you need to check whether the quadratic equation is written in its standard form. Now, if it's not written in standard form, then you need to rewrite it into its standard form, in the form ax squared plus bx plus c equals 0. Then number 2, you apply your knowledge, your prior knowledge about factoring quadratic expression. Okay, so number 3 step is to apply the zero product property by equating each factor of the quadratic equation to 0. So the zero product property states that if the product of two real numbers is 0, then either of the two is equal to 0 or both numbers are equal to 0. And thus, you solve the equation. Okay, so let's take first example 1. Find the solutions of x squared plus 8x equals negative 15 by factoring. So please take note, class, that when we talk about solutions, we are referring to the values of x that could satisfy this given equation. So what should be the values of x so that when I replace x with that value, I will get negative 15. Okay? So these are the steps that we need to follow in order to get the solution for this equation. So number 1, transform the quadratic equation into the standard form if necessary. Take note, only if necessary. So we can do that by checking first the given equation, whether it's written in the standard form or not yet. So in this case, it's not yet written in the standard form of the quadratic equation. So we need to rewrite it. Okay, so the standard form now is x squared plus 8x plus 15 equals 0. Okay, so that is now the standard form of the given equation. Then number 2, we need to factor the quadratic expression x squared plus 8x plus 15. So by factoring, we get these factors, which are x plus 5 and x plus 3 equals 0. Okay, after that, we apply the zero product property by equating each factor take note, equating each factor of the quadratic expression to 0. So since our factors are x plus 5 and x plus 3, so we need to equate each factor individually. So it becomes x plus 5 equals 0 for the first factor and x plus 3 equals 0 for the second factor. Okay, after that, we solve each resulting equation in order to get the value of x. So for x plus 5 equals 0, we have x equals negative 5. How did we get negative 5? We transpose 5 to the other side, so that becomes now negative, since we are taking the opposite sign whenever we transpose a term to the other side of the equation. So our first value for x is negative 5. Now, for the factor x plus 3, okay, we equate it to 0. Then we have the resulting value for x, which is negative 3. Okay, so now how do we know that these values for x that we have generated are really the solution to the given equation? So let's find out by checking. So we have already solve the solution to the given equation. So now it's time to check whether our answer is correct or not. Whether the solutions that we were able to solve are correct or not. So how do we check the answer? So number one, we go back to the original equation given in example 1. So the original equation is x squared plus 8x equals negative 15. After that, we substitute the solution or solutions to the original equation. So in this case, our solutions are negative 5 and negative 3. So for x is equal to negative 5, so after substituting, we have come up with these two equating values. Negative 15 is equal to negative 15. Therefore, negative 5 is a solution to this equation, x squared plus 8x equals negative 15. How about for x is equal to negative 3? So we substitute by replacing the x in the equation with this value, which is negative 3. So negative 3 squared plus 8 times negative 3 equals negative 15. So negative 3 squared is 9 plus 8 times negative 3 is negative 24 equals negative 15. We add 9 plus negative 24, so the resulting value is negative 15 and it's equal to negative 15. Therefore, the solution to the equation, to this equation rather, are correct. So let's now go to example 2. Find the solutions of negative 8x equals negative x squared plus 20. Okay, same process that we did earlier. First, we need to transform this given equation into the standard form of the quadratic equation. So its standard form now is x squared minus 8x minus 20 equals 0. Then after that, we apply the factoring technique. So the factored form of this equation is x minus 10 times x plus 2 equals 0. Then we apply the zero product property by equating each factor of the quadratic expression to 0. So in this case, it becomes x minus 10 equals 0 and x plus 2 equals 0. Then we're going to solve now the values for x. So you have x minus 10 equals 0. You transpose negative 10 now, it becomes positive, so x equals 10. On the other side, we have x plus 2 equals 0. Then we transpose positive 2 to negative 2, so the resulting value is x equals negative 2. Now it's time to check our answer. Okay, so again, we go back to the original equation given in example 2. So in this case, it's negative 8x equals negative x squared plus 20. Okay, then we substitute the solutions to the original equation. So our solutions are 10 and negative 2. Okay, we substitute it by replacing the x with the solution. Okay, for x is equal to 10, so that is negative 8 times 10 equals negative, okay, 10 to the second power plus 20. So negative 8 times 10 is negative 80. Then 10 squared is 100. Then don't forget, we have the negative sign outside the parentheses. Then plus 20. So we simplify it now. Negative 80 is equal to negative 80. Okay, how about for x is equal to negative 2? So same thing, we need to substitute it by replacing x with the value which is negative 2. So negative 8 times negative 2, that is positive 16. So negative 2 squared, that is 4, but we have a negative sign outside, so that becomes negative 4 now. Plus 20, so negative 4 plus 20 is positive 16. So as you can see, the equating values are the same, 16 equals 16. So the solution, negative 2, is correct. So we're now ready to solve example 3. Find the solutions of 36x squared equals 49 by factoring. So again, it's not yet written in standard form. Then we need to rewrite it into its standard form. So in standard form, this is 36x squared minus 49 equals 0. So as you can see, the first term is a perfect square, and second term, which is 49, is also a perfect square. So it's a difference of two squares. So we can apply the special product technique. Okay, so the factored form is this quantity 6x minus 7 times the quantity 6x plus 7 equals 0. So by applying the zero product property, we have 6x minus 7 equals 0 and 6x plus 7 equals 0. Okay, so we're now ready to solve for the values of x. So 6x minus 7 equals 0. After transposing 7 to the other side, we have generated 6x equals 7. Then divide both sides by 6. So the answer is x equals 7 over 6, or 1 and 1/6. Okay, on the other side, we have 6x plus 7 equals 0. Then same thing with what we did earlier. So we transpose the constant to the other side, so that becomes negative 7. Then divide both sides by 6. So the answer is x equals negative 7 over 6, or negative 1 and 1 over 6. Okay, so again, we need to be sure with our answer. So we need to check by substituting these two values to the original equation. Okay, so let's now check our answer. So our solutions to the given equation are 7 over 6 and negative 7 over 6. So it's fraction. Okay, we replace the x here with these two values. Okay, one for x equals 7 over 6, we have this one. 36 times, okay, 7 over 6 to the second power equals 49. Then, so 7 over 6 squared, that's equal to 49 over 36. So we cancel 36, so leaving us with 49. So 49 equals 49, so that's checked. Now for the other one, we have x equals negative 7 over 6. So we have 36 times negative 7 over 6 to the second power equals 49. Then negative 7 over 6 squared, that's 49 over 36. So we cancel 36, leaving us with 49. So that 49 equals 49. So same thing is correct. So therefore, the solutions to the equation 36x squared equals 49 are 7 over 6 and negative 7 over 6. So this time, let's take example 4. Find the solutions of 4x squared equals 20x by factoring. So again, it's not yet written in the standard form of the quadratic equation. So we need to rewrite it first into its standard form. So the standard form is 4x squared minus 20x equals 0. After that, we factor it. So what do you think is the appropriate factoring technique that we can apply here to get the factors? Okay, so we can use the greatest common monomial factor. So what is common among this? What's common? So the common factor is 4x. So 4x, we can generate the other factor, which is x minus 5. So we have now 4x times x minus 5 as factors for this equation, and we equate it to 0. Then number 3, again, we apply the zero product property by equating each factor of the quadratic expression to 0. So since our factors are 4x and x minus 5, so we equate each factor to 0. So this now becomes 4x equals 0 and x minus 5 equals 0. Then we can now solve each resulting equation. So for 4x equals 0, then we have x equals 0 when we divide 0 by any number, we always get 0 as its quotient. 0 divided by 4 is 0. But any number divided by 0 is undefined or cannot be. But in this case, since it's 0 divided by 4, 0 divided 4, therefore the answer is 0. Okay, so for x minus 5 equals 0, we transpose negative 5 to the other side, then we have x equals 5. Therefore, the solutions to the equation are 0 and 5. Now, let's check whether these solutions satisfy the given equation. So let's substitute now. Let's check now our answer. Okay, so we are now ready to substitute our solution to the original equation. We have 4x squared equals 20x. That's the given equation. So we need to replace this x with the solution that we were able to generate. So for x equals 0, we have 4 times 0 squared equals 20 times 0. So that's 0 equals 0. So correct. So therefore, x is a solution to this equation. How about for x equals 5? Okay, we substitute 5 to the variable x. So 4 times 5 squared equals 20 times 5. So 5 to the second power is 25. So 4 times 25 is 100. And 20 times 5 is 100. So 100 equals 100. So that's check. Therefore, the solutions to the equation for x squared equals 20x are 0 and 5. So let's try your understanding about the lesson by answering this exercise, SQE exercise. Solve the following quadratic equations by factoring, then check your answer. Okay, so you have 3 numbers here. and we're going to discuss the lesson next week.